I think fluids are fascinating and awesome, but it is not just me who's intrigued by how things flow. Legend has it that a man once ran naked through the streets because he was so excited about discovering an important property of fluid: buoyancy. But first, let's start with the basics. We've described the physics of objects based on their mass, but when it comes to fluids, we mostly use a different term: density, represented in equation by the Greek letter rho, which is mass divided by volume, and it's measured in kilograms per meter cubed. If an object or fluid is made up of heavier atoms or molecules, or those particles are packed more closely together, then it's going to have a higher density. Let's go back to the legend. Who is the man who ran naked through the streets, excitedly yelling Eureka? That was Archimedes, and he lived in Greece in the 3rd century BCE. He discovered that when you put something in the fluid's volume increases by the amount of the object's volume. This tells us a lot about what makes object float or sink. Take for an instance are these two oranges of the same size. One is peeled and the other is not peeled. We can observe that the force from gravity that's pulling down on the peeled orange is stronger than the force that is pulling down on the unpeeled orange. Hence, there's a net downward force on the peeled oranges that causes it to sink at the bottom. Why so? The orange peel itself has tiny pockets of air in it. The force of gravity pulling it downward is weaker than the force of the peeled oranges, and there's a net force upward on it that causes it to float at the top. This is called buoyancy force. Buoyancy is the ability or tendency to float in a water or some other liquid. Hence, Archimedes Principle states that there's a buoyant force pushing upward on an object in the water, and it's equal to the weight of the water that the object is displaced. This is why a cruise ship floats in the ocean. Steel is very dense, but the air in all the cabin is not. So overall, the ship is less dense than water. In this way, the buoyant force can be expressed as the gravitational force of the displaced fluid equals to the mass of the displaced fluid times acceleration due to gravity. And thanks to Archimedes, we know why objects float and sink, and maybe next time, you will have your own Eureka moment too.